Okay, and the third type of microphone, which is an entire category on its own, it bears some time to discuss how it actually works, is called a condenser microphone. Now, a condenser microphone is probably the most quality microphone you see in a studio. The vintage Neumanns, the vintage AKGs, those are all condenser microphones, and they're considered to be the best sounding mics. So people have called it a capacitor microphone. We discussed what a capacitor was, right? A capacitor was two plates of metal that don't touch each other but are charged in different ways. They're charged oppositely, and when more charge goes onto one plate, say one plate gets more charge, it attracts more charge to the other plate to counterbalance it, because positive attracts negative and negative attracts positive. But this is electrical, totally electrical, non-magnetic. So the way that this works, if you look at the slide, you've got a diaphragm, very thin diaphragm. Actually, I'll draw it as well so that you can see it. So you've got, on this diagram, you've got sort of a solid plate here, and then you've got a very thin diaphragm here with an insulation between. When sound energy hits the diaphragm, now the way it works is that this is connected to a wire, and the diaphragm and the back plate are connected to different wires. And then there's a power source of some sort and a resistance of some sort. And these all connect. So what happens is, as sound hits the diaphragm moves. It is already charged with positive or negative energy from your power source of your battery. So we've got a battery charging up the condenser microphone. So one side is positive, one side is negative. And when sound energy hits the diaphragm and it moves back and forth, it gets closer and further away from the back plate. When it gets closer to the back plate, it attracts more of the opposite charge. When it's further away, the energy attraction is less, and these go the other way, and you get less of them. So you get some current flow this way and this way, going back and forth through this system. And since this is a resistor, you've got current flowing through a resistor, you obviously have a voltage between that fluctuation. And that voltage is detected and sent out. And it's very, very, very small amount of voltage fluctuation that it captures. Inside the microphone itself, there's usually a small preamp that actually gives it a little amplification so that it can come up to the normal microphone level, so that it can be acceptable to go into a microphone mic preamp, which is actually a special amplifier to bring microphones from their very low level to the standard level of the studio, which is line level. So it's even quieter than the standard microphone. So inside of the microphone itself, you've got a power source like a battery of some sort powering this, and there's also an amplifier to bring it up to normal microphone level. That tells you how sensitive they are. So very small fluctuations can be detected by this circuit, and so it's an extremely sensitive microphone. The other way that this is powered up, and condenser mics don't work unless there is power. If there's no power, condenser won't work because it only works on electrical charge. It doesn't work on magnetism of any kind. Whereas the moving coil dynamic and the ribbon microphone really work with no power source at all. It's just the principle of magnetism and electricity and how they interact. But this needs a power source to create the system whereby you can detect small motion in the diaphragm. The ways that you can power it up is with a battery. Let's say you're on location at a film shoot and you really want to use a condenser microphone. They've got these microphones with battery packs inside the microphones. But in the studio generally, you don't have those kind of microphones with battery packs, but you get power source from the board. So wherever you plug this microphone into, the microphone mic pre that you plug it into gets a power source. The power source is called phantom power. So if you look at your little boards, usually not on live boards because performance reinforcement usually uses dynamic microphones. Because they're less sensitive, you pick up less stage volume and sound you don't want. But in a studio, you really want to pick up what's really happening with the piano or the cello or the vocalist. So you need a sensitive microphone. And so when you plug it into your microphone mic pre, you usually have a switch that says phantom on or phantom off. And what it is it's 48 volts, and it comes from your mic pre. So if I were to draw this so you understand more clearly, say you've got a condenser microphone, and it's hanging here, and you've got a vocalist singing and so on and so forth, and they're singing into the mic. The mic itself, through the cable, goes through the wall, through a panel, into the control room, where it connects to the board in the control room. And this microphone mic pre it connects to has a switch that allows it to send phantom through the cable that it's connected to back to the microphone to power it up. Without phantom connected, it won't work, right? So if you forget to push the phantom button, your microphone won't work. You have to sort of power it up to make it work. Now, on the other hand, when we talked about the ribbon microphone, if you have this system in place and you accidentally press phantom power, it's going to send current and voltage back to the microphone. And what happens when current flows through a wire and it's in the proximity of magnetic fields? It creates its own magnetic field, which is either positive or negative to the magnets that are already in place, and it'll push the diaphragm forward or backwards very hard, very fast, and it will bend the diaphragm and destroy your microphone. So one of the first things I tell second engineers, if you have a ribbon microphone, never, ever, never, ever, ever, never, 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 ever let phantom power touch that microphone, because it will destroy it. I know personally because I've done it, and it was really an unhappy situation. It cost me a lot to get the microphone repaired. So, because they're sensitive, they will destroy themselves if you do the wrong thing. Of course, if you drop it, it's even worse. So, you got to be very careful with microphones. It's kind of like your laptop. You don't want to drop it. You can dent it, but eventually it'll break if you do that. So the condenser mic is what's normally used in the studio, and it's the most sensitive type of microphone, which means that it generally has the highest frequency response. And that's a good thing for certain kinds of sound recordings. But then on the other hand, being so sensitive, it can also be a problem, because if I've got an electric guitar that's really loud and I'm using a condenser mic because it has such great frequency response, I can basically distort it because it's getting so much sound energy. It's creating so much charge displacement that the internal mic pre inside the microphone will overdrive and get distorted. And I've used that effectively at times with vocalists, for example. If they sing real loud, there's times when I can use the microphone to get a little distorted edge on their voice, which makes them cut through more. I wouldn't recommend it. It's not the proper way of doing it, but I did it accidentally and I liked the way it sounded. But these kind of condenser mics, usually on the body of the microphone, have a switch that's, say, minus 10 dB, minus 15 dB, and it's basically to protect it from overloading. So you have to be sensitive to the fact that they're very sensitive microphones, and you can't bombard them with loud sound without being careful not to overload it. But then on the other hand, a microphone that's less sensitive, like a moving coil dynamic, like an SM57 or an SM58, is just perfectly suited to go in front of a guitar amp or to sit in front of a snare drum that's being hit, that's really loud. Because it is moving coil, it takes a lot of energy to move the coil, and it'll pick up a lot of great sound quality because there's so much energy hitting it. So you've got to kind of think of which microphone choice you want for a specific sound, but also how loud is it going to be, because certain microphones are very sensitive, some aren't. This is the phantom power system I was discussing. The standard scheme is that the phantom usually comes from the microphone mic pre. And I call it phantom. I don't know why it was ever called phantom. Oh, I know why. Probably because it does nothing except it stays in the background and it just powers up the microphone. There's no real current flow because, as I showed you before, the plates don't touch. So no current can actually flow through the wire. It just is to supply charge to both plates. It's just my assessment of why they call it phantom. I don't really know. But it's a DC voltage. And we all know what that means, direct current.